Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at permutations. Now, permutations are ordered arrangements. We've already been doing permutations, but in those, we took every one of the possible objects and arranged it. Here in this video, we're going to look at what happens when we only take R objects, when we only take some of the objects of a collection and arrange them in order. So this notation NPR suggests you're permuting, permutations, R objects from a group of N. And this is the formula. I'll show you why that works. So let's say of my 10 favorite students, I pick 4 of them at random. How many ways can they be arranged in order? So let's say my 4 favorite students are A, B, C, and D. That is one possible permutation, or B, A, C, D is another. I don't want to write them all out because sometimes that will take forever. So what I'm going to do is use what we already know about arrangements. See, in the previous video, we looked at arrangements with restrictions. So we know that we have 10 choices for the first, then 9 for the second, 8 for the third, and 7 for the fourth. You can do this question this way. That wouldn't take too long. But of course, if I was picking, say, 40 or 50 students, it would take forever to write out all these numbers. So we already have factorials. Why not use them? So the total number of permutations here, I could write as this. I could put in all these numbers so I can make the top equal to a factorial, as long as I divide this on the bottom. So you can probably see that what is written in blue I can cancel out. This fraction just equals 10 times 9 times 8 times 7. But writing it out like this shows how we can more easily put it in our calculator. It's just going to be 10 factorial divided by 6 factorial. So we were picking 4 from 10. It's 10 factorial over 10 minus 4 factorial. That's how we arrived at our formula up here, n factorial over n minus r factorial. Introducing the factorials just makes it easier to put in our calculator, so we don't have to write out a ridiculously long string of numbers. So you should be able to input this into your calculator as 10p4. Either way you put it on the calculator, there are 5,040 ways that we could arrange them. Luckily, we didn't try and write out all of these. All right, let's now look at a harder question. So there are 12 horses in a race, each with the same probability of winning. I bet on 3 horses. Let's calculate the probability that each of those finishes in the top 3. So that is, if I bet on horses A, B, and C, they finish in the top 3 in any order. So A, B, C, B, A, C, whatever. So the number of ways that this can happen, the number of ways that my horses A, B, and C can finish in the top 3 is 3 factorial. There are 6 possible arrangements of my 3 horses that I bet on. So I could have A first, B second, C third. I could have B first, C second, A third, and so on. So that's the number of ways it can occur. Now, what is the total number of outcomes? Well, what we're doing is we're taking from 12 horses, picking 3, and arranging them in order. So you can put this straight in your calculator just like this, and it reduces to 1 over 220. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.